Rutherford's model of an atom. Rutherford's scattering experiment. In 1911, Rutherford performed an experiment in which he bombarded a thin foil of a heavy metal like gold with a team of fast-moving alpha particles, which are doubly ionized helium ions, He2+, each having 2 units of positive charge and 4 units of mass, 4U. These were obtained from radium placed in the cavity of block of lead and made into fine beam with a slit. He observed the scattering of the rays after hitting the foil by placing a circular zinc sulfide screen around the metal foil. Wherever alpha particles struck the screen, a flash of light is produced at that point on the screen. That the heavy body present in an atom must be occupying a very small volume. From these experiments, Rutherford made the following observations. Most of the particles, that is 99.9%, passed through the foil without undergoing any deflection. Some particles were deflected through small angles, and a few were deflected through large angles. Very few, only 1 in 12,000, were deflected back, that is, through an angle greater than 90 degrees. From these observations, Rutherford drew the following conclusions. Since most of the alpha particles passed through the foil without undergoing any deflections, there must be sufficient empty space within the atom. This small, heavy, positively charged body present within the atom was called nucleus. Rutherford's nuclear model of an atom. On the basis of scattering experiments, Rutherford put forward a model of atom known as Rutherford's nuclear model. There is a positively charged center in an atom called the nucleus, in which all the mass of an atom resides. The size of nucleus is very small as compared to the size of an atom. The electrons revolve around the nucleus in well-defined orbits. As some of the alpha particles were deflected by small angles, and since alpha particles are positively charged, they could be deflected only by some other positively charged body present within the atom. The alpha particles which deflected through small angles were those which passed far from this positive body. The alpha particles which deflected through large angles were those which passed close to the positive body. Since some alpha particles were deflected back, alpha particles are heavy particles, they could be deflected back only when they strike heavily inside the atom. Since number of alpha particles deflected back is very, very small, which shows that the positive charge and mass of gold atom must be occupying a very, very small volume. Drawback of Rutherford's model of an atom. According to Rutherford's model, an atom consists of a small, heavy, positively charged nucleus in the center, and the electrons were revolving around it. Whenever a charged particle like electron is revolving around a central force like that of nucleus, it loses energy continuously in the form of radiations. Thus, the orbit of the revolving electron will keep on becoming smaller and smaller, following a spiral path, and ultimately, the electron should fall into the nucleus, which means the atom should collapse. But this actually does not happen, and the atom is quite stable.